And then we have the second method, which is the steady state model, and this is known as Schiltuis model. For this model, we assume this is the simplest aquifer model. Assume that the rate of water influx is proportional to the pressure drawdown. So WE is proportional to the pressure drawdown, which is delta P. And in this model, we assume that the aquifer volume is much larger than the gas reservoir and remain at the initial pressure. So the aquifer volume is assumed as a large compared to the first, the simple equation. And the equation that we use for the water influx is WE equals to K. K is a constant, 0 to T integral. So 0 is your initial time of production, 0, and T is your ongoing time. Pi, initial pressure, minus P, the integral over dt. And then you will get this equation to use. So constant K, you have your Pi minus Pj plus Pj minus 1 over 2 times your time. So it's pressure and time changes. So this video will show how actually the water influx happens. If you can see here, when the production starts, you have pressure here, and as we produce from the well, the pressure will starting to drop in the reservoir. And then the green one is the water to oil ratio. So over time, your water will oil ratio will start to increase, meaning that water will increase and oil will decrease. And for GOR, gas oil ratio, it remain the same. So as you can see here, when the oil is produced, your gas remain the same, but your oil will reduce because it's been produced to the surface. And this water, the existing water, will started to fill in the space of the oil in this part of the reservoir rocks. And this oil will start, volume will start to reduce, means that your green graph here, water oil ratio will increase until here. So at this point, actually, your oil will starting to be less than your gas gap. The oil will be lesser than your gas. So gas oil ratio will increase. So this method is using that concept.